Hi there, in this video I'm going to go over this problem that we looked at in school. So the question says that Steve is running at 1.5 meters per second, Jim runs faster, but Steve has a 40-second head start. So I think the most important thing to do here is to start off with a good graph of what's actually happening. So here's a position time graph. Steve, let's see, it says he starts at, or he's going 1.5 meters per second. So if we think of time in terms of clock reading, we can say that Steve starts at time 0 and goes some speed like that. And then there is Jim. Jim is given, Steve is given a 40-second head start, so that means Jim starts after Steve. So we'll call that, say, 40. So the way this works is if you can imagine something at a stopwatch, Steve starts when you start the stopwatch, and then when the watch hits 40, that's when Jim starts. And he runs like this. And they meet at some point. This is where, that's the time that takes for Jim to catch Steve. So, some point like that. Call that time t, and maybe we'll just call this position xf. So that's the final position. So to analyze this, I think the first thing we should do is think about the equations for each one of these runners. So this line here, of course, it has the form y equals mx plus b. Well, in this case, we have x of Steve. I'm going to call it s for Steve. Equals the slope of that line is the speed, so it's 1.5 t, and there's no y-intercept. So that one's pretty straightforward. When we model Jim's motion, same thing. It's y equals mx plus b. So it's x of Jim, so xj, equals his speed is 2.5, and there's some y-intercept that we don't know yet. So those are the two equations that we're dealing with, 1 and 2. So I think the first thing we need to do is figure out what that value is. What is the y-intercept for Jim? And it's not that hard to do. We can actually sketch it on a graph here. That's the y-intercept for Jim. And how can we go about figuring out what that is? Well, we have an equation here with, oh sorry, this is supposed to have a t on it. There we go. We have this equation, and it has one unknown on it, which is the y-intercept. We can figure this out by plugging in a known point. So we actually know this point. That's the only point we know for sure. The coordinates of that point are 40, 0. So if we plug that point into this equation, we can solve for the b. So the position there is 0, and the time is 40 plus b. So that means 0 equals 100 plus b. So b equals negative 100. So we can then say that the equation for Jim is xj equals 2.5 t minus 100. Great, so now we have the equation for the two lines. And the final thing we need to do is we're going to figure out that where they meet is at the same position, which is x of f. So x of f is equal to, or we could say even better, at x of f, x of Steve equals x of Jim. So we could say that 1.5 t, that's x of Steve, is equal to 2.5 t minus 100, which is x of j. And now we can solve this equation for t. So we get minus 2.5 t from both sides. We get negative 1t equals negative 100, and we get t equals 100 seconds. So to actually fully answer the question then, at what time does Jim catch Steve? At the time, which is a clock reading of 100 seconds. Another way to think about that is it takes Jim, he started at 40 seconds, it takes Jim 60 seconds to catch Steve.